Hello. The purpose of this video is to refresh your memory about some of the things we learned in class about a category of compounds called hydrates, in particular how to determine the formulas of hydrates by measurements and calculations. Just to remind you, a hydrate is defined as an ionic compound that contains water molecules that are trapped inside its crystal lattice. We can represent a generic hydrate with the formula Mx dot NH2O. What this means is that we've got an ionic compound represented by Mx. The N represents the number of moles of water per mole of ionic compound Mx, and N is always a small integer. So our goal is to figure out the complete formula of the hydrate by figuring out what that value of N is. N is sometimes called the degree of hydration. Well, we do this experimentally by simply taking a sample of the hydrate and heating it, driving the water off from the crystal lattice into the vapor phase, leaving behind just the Mx, which is referred to sometimes as the as the anhydrous salt, anhydrous being the fancy term for dry. And of course the N water molecules just escape into the vapor phase. So by measuring the mass of the anhydrous salt that's left after drying it and subtracting that from the mass of the original hydrate, we can calculate the mass of water that was given off. So let's do a couple of examples. Here's a problem just like the one we did in the laboratory. A sample of a hydrate of chromium-3 chloride with a mass of 3.572 grams was heated until no more water was released. We then measure the mass of the resulting anhydrous salt. From that we can figure out the formula of the hydrate. I'm going to begin by writing an equation because we're going to obviously need the formula. Chromium-3 means a chromium cation with a 3+ charge. The chloride anion, of course, is Cl-, so that lets us write the formula as CrCl3 dot NH2O. And I'm starting with 3.572 grams of that. I'm heating it, driving off the water, leaving behind anhydrous chromium-3 chloride with a mass of 2.663 grams and forming water that goes away into the vapor phase. So the first question is how many grams of water were produced. We'll calculate that simply by doing a subtraction. 3.572 grams of the hydrate minus 2.663 grams of the anhydrous salt gives us 0.909 grams of water. Now keep in mind that N, the degree of hydration that we're trying to calculate, is a mole ratio. It is simply the moles of water present divided by the moles of chromium-3 chloride. So all I need to do to calculate the moles of water in chromium-3 chloride is simply convert from grams to moles, which you know how to do. For that we'll need molar masses, so let's calculate some molar masses. For chromium-3 chloride, I've got the molar mass of chromium plus 3 times the molar mass of chlorine, which is equal to 158.35 grams per mole. For water, I've got 2 times the molar mass of hydrogen plus the molar mass of oxygen is 18.02 grams per mole. Great, now I can simply take the masses that I measured up above and convert them to moles. So my moles of water are 0.909 grams over 18.02 grams per mole, or 0.0504 moles. My moles of chromium-3 chloride are 2.663 grams. Make sure you use the mass of the anhydrous salt, not of the hydrate. Divide that by 158.35 grams per mole, and I get 0.0168 moles of chromium-3 chloride. As I said before, N is simply a mole ratio. It is the moles of water present in a crystal lattice per moles of chromium-3 chloride. So all I do is take the two results I just got and divide them. 0.0504 moles of water over 0.0168 moles of chromium-3 chloride, which is equal to exactly 3. If you don't get something really, really close to an integer at this step, you know you made a mistake. Go back and check your math. So that lets me conclude the problem by writing the full formula, chromium 3 chloride dot 3H2O, or trihydrate. And there is my final answer. Now, another way you could be given information about the composition of the compound would be not in terms of the masses of the hydrate and of the anhydrous salt, but instead of the mass percentages. So here's a problem similar to one on the worksheet. A hydrate of sodium hydrogen phosphate was found to contain 47.05% water by mass. Determine the formula of the hydrate. So again, let's begin by writing the formula. The sodium cation is Na+. The hydrogen phosphate anion from your nomenclature sheet has the formula HPO4 with a 2 negative charge. That means the whole formula is Na2HPO4 dot NH2O, decomposing to form Na2HPO4 plus NH2O. In this problem, we're not given masses of the hydrate and the anhydrous compound, but we are told that it's 47.05% water by mass, so logically, to calculate the mass percentage of sodium hydrogen phosphate, we simply subtract the mass percentage of water from 100. So 100.00% minus 47.05% means that I have 52.95% sodium hydrogen phosphate by mass. Now I'm at the point where I was before, where I can simply assume that I have 100 grams, convert percentages into grams, and then simply divide by the molar mass. I will spare you the calculation of the molar masses, since I know you know how to do that. The molar mass of sodium hydrogen phosphate is 141.96 grams per mole. N then is simply moles of water over moles of sodium hydrogen phosphate. Let's just combine this in a single calculation. I can simply, for the numerator, take my 47.05 grams of water, divide by the molar mass of water. In the denominator, I'll take my 52.95 grams of sodium hydrogen phosphate, divide that by 141.96 grams per mole. You can do that on your calculator in a single step, and what you get is N is simply equal to 7. So the final formula is sodium hydrogen phosphate dot 7H2O, or as we would say, sodium hydrogen phosphate heptahydrate. So there you have it.